welcome everybody to our last developmental disability rounds for the 2019-2020 academic year. And to end the year, we will go out with a bang. So we are really happy to welcome Dr. Fakhri Shafai. Fakhri is a postdoctoral fellow in the Department of Psychology and the Brain and Mind Institute with Ryan Stevenson at Western University. Her doctoral research at the University of British Columbia focused on the perception of basic visual stimuli, face recognition, and face expression processing in adults and individuals with autism and people without. Her research currently is expanding into multisensory processing using behavioral and neuropsychological measures combined with advanced neuroimaging techniques such as fMRI. She also is interested in painting, exploring the outdoors, and playing board games. And maybe, Fakhri, at some point you can let us know which board games in particular you like to play.
Sounds good.
Go ahead.
Oh, say which board games now?
Well, anytime you want. Actually, I was.
I'm a big fan of Pandemic and the Seven Wonders. I've
never heard of either of them, but they sound good. Especially Pandemic seems very appropriate at this time.
It's a little too appropriate at the moment.
Okay, so welcome. You're up.
Wonderful. Thank you so much. I'm going to share my screen now. All right, so today I will be talking about emotion processing in autism and what sort of insights we can find from eye tracking and pupillometry studies. Today's learning objectives. By the end of this talk, participants should be able to describe the background and influential eye tracking studies related to emotion processing in autism. Summarize the current evidence demonstrating how autism traits in the general population are related to pupil responses in observed emotions. And understand the results of an in-progress study assessing pupil responses to observed emotions in autistic children and adults. So diving right into our first objective. Many people are familiar with common causes of pupil dilation, including light versus dark. We know that in the light, pupils constrict, and in the dark, they expand or dilate. Pupils also constrict or dilate in response to trying to look at something that is close up versus something that is at a further distance. Medications and drugs can induce pupil dilation, and certain brain injuries also can induce pupil dilation. There are other less commonly known causes of pupil dilation, and those include physical attraction. When the sympathetic nervous system is activated, so if the person is entering a fight, fright, or flight state, their pupils will dilate. Mental effort, so if somebody is doing a difficult task, their pupils will respond and indicate that their brain is being taxed at that moment. And observing other people's emotions. Importantly, the observation of other people's emotions is something that I will be diving into in more detail when I describe the studies in Objective 2 and Objective 3. I realize that most of this audience is familiar with autism spectrum disorder, but to ensure we are using a common definition, I will describe the criteria for diagnosis as stated in the latest Diagnostics and Statistical Manual of Mental Disorders, or DSM-5. The DSM-5 was released in 2013 and made the important distinction of using autism spectrum disorder as an umbrella term, where there were two areas of two core deficits. The first being social communication and social interactions. And then the other core area of deficits being in restricted, repetitive patterns of behavior, interest, or activities. These categories were both then broken into severity levels, where a level 1 means requiring support and a level 3 requiring very substantial support. As social communication and social interaction are core areas of the umbrella term for autism spectrum disorder, many studies have explored the causes and attributes of these particular deficits. Eye tracking studies have been an important tool in understanding how social communication and interaction difficulties present in the ASD community. They allow us to assess attention and arousal even in nonverbal individuals. Going to describe a few studies in this area right now. So autistic individuals have different attention in social scenes. So in this image here on the right, you can see what we call a heat map, and the red areas represent where more attention is paid for a percentage of time during an eye tracking study. And on the top here, we see a neurotypical image, or we see images or the results from neurotypical participants. And as you can see, the most attention was paid to the face area for neurotypical participants. Autistic individuals between the ages of 8 and 28 were shown static images of nature or images with people. And the autistic individuals were more likely to look at the objects in the background instead of the faces of people in the image. So here on the bottom, you can see more attention was paid to the handkerchief or the pillars in the back. For our second study, one of the things that people have found is that attention to faces is also different. So when a person on the spectrum is looking at a face, they're not necessarily looking at the same part. So in general, they tend to look at the mouth or other areas of the face as opposed to the eyes. In this study, which was notably the first eye tracking study published looking at autistic individuals. Autistic adolescents and young adults were shown video clips, and it was found that they looked more at the mouth instead of the eyes of the people in the scenes. And importantly, less attention to the eyes was a predictor for social competence in ASD. The less they looked at the eyes, the more severe their symptoms. And finally, these findings have led people to suggest that eye tracking studies could be a potential biomarker for infants at risk for ASD. In this study, 2 to 6 month old infants who were at high risk for ASD, they have an older sibling that had been diagnosed, were asked to do an eye tracking study where they were looking at videos of a woman talking to them. On the right, we see individuals or infants that were not at risk, and we can see that the blue represents where their eyes spent the most of the time, and in general, they were looking at her eyes, or at least her forehead region. However, for the infants who would later go on to be diagnosed with autism, we see more attention is being paid to their mouth and to their hands. So even as early as 2 to 6 months of age, we can actually see these differences early on. Since emotion processing is such an important part of social interactions, eye tracking studies have been expanded to look at how individuals on the spectrum process emotions. In this first study, we see what's called a bubble paradigm. And while it's a little terrifying to look at, the idea with the bubble paradigm is that the participant will look at a particular area, and only the area they're looking will be clear. Everything else will be blurred. And on the left, we see HFA representing high functioning autism. And on the right, we see controls. And then when we subtract high functioning autism from the control results, or the controls from the high functioning autism results, you can see that for individuals on the spectrum, they make more use of the mouth region when trying to decide if a person is fearful or happy, while controls make more use of the eye region. In the second study, Autistic children through adults were asked to look at faces and identify what emotion it was. Importantly, they also added developmentally disabled and age and IQ matched peers. So on top, we have the neurotypical. In the middle, we have the DD group. And then on the bottom, we have the ASD group. The autism and the DD group both had significantly less attention to the eyes compared to the TD group. So why would we use pupil dilation in studies of autism? Well, one is that it is a reflection of the autonomic nervous system. Remember that I said pupils will respond when faced with an emotionally taxing activity or when observing or experiencing strong emotions. Importantly, these studies can be done with nonverbal participants. They are relatively quick measurements, and they are far less expensive and more comfortable than other measures of neural activity like EEG or fMRIs. I'm going to walk you through some important pupil dilation studies in autism. In this study, participants were shown an unopened box and then a video of a woman opening the box and her showing her reaction. The participants did not see what was actually in the box. And there was a significant difference in the percent pupil change for the typically developing group, but not for the ASD group. They did not respond as strongly on an autonomic level. In the second study here, I'm going to walk you through what this all means, but on the bottom axis, we see time in seconds, and then on the y-axis, we see the percent pupil increase. And autistic children will show images of faces expressing emotions while either looking directly at the participant or with their gaze averted. And the percent pupil increase was calculated using a different score for the direct minus the averted. And this was plotted at each time point. They tested happy, neutral, fear, and angry. And red, which represents happy, was significantly different from the other emotions. For this typically developing group, happy expressions with a direct gaze induced the largest pupil increase, which the authors argued was an index of social reward. Now, if we look at the ASD results on the top, there was no such difference between the different groups, and the authors argued that this was an indication that there is less social reward in autism. I would like to note that these findings are not universal. Some groups have found no differences or even more pupillary responses to certain emotions in ASD. It is believed that these discrepancies likely reflect differences in participant sizes, methods, static versus dynamic images, or heterogeneity in autism. So in summary, in autism, eye tracking studies and pupillometry studies, in general, there's less time attending to faces. And when they are attending to faces, they tend to spend more time looking at the mouth as opposed to the eyes. And in general, there is less pupillary response to emotions. We're going to move on to objective 2 now. So in this study, which is complete and in preparation for submission for publication, we had 100 undergraduates participate in this study. Their mean age was 18.8, and there were 65 females. Participants were asked to fill out a number of questionnaires related to autism or social competence, including the Autism Spectrum Quotient, or AQ, the Broad Autism Phenotype Questionnaire, or BAPQ, the Repetitive Behaviors Questionnaire, or RBQ, the Social Responsiveness Scale, and the Multidimensional Social Competence Scale. The Sensory Perception Lab in the Brain and Mind Institute received a grant for this cutting-edge technology. We were able to obtain a portable eye tracker, which is essentially just a bar that can attach directly to your computer screen. Importantly, this minimizes the discomfort associated with asking participants to wear bulky glasses or have a variety of cameras pointed at them. And it allows us to test on both desktop and laptop computers, which allows us to take our experiments out of the lab. The cameras in the eye tracker are able to measure changes in pupil diameter in addition to being calibrated to detect when a participant is looking at areas of interest on the screen or if they are moving excessively during testing. For this experiment, we did still have our participants use a chin rest, and this experiment took place in a dark room so that we could be sure any changes in pupil diameter were related to the stimuli on the screen and not due to lighting conditions in the room. We chose the Ryerson Audiovisual Database of Emotion, Speech, and Song, or the RABDES, for our stimuli. And in these videos, actors say the phrase, "Kids are talking by the door." But they say it with different emotions and different intensity. So there's a low and a high intensity condition for angry, disgust, fear, happy, sad, and surprise, and then a single neutral condition. I have examples of these videos following this slide. We chose 20 actors, 10 male and 10 female. And there was a single presentation for each video, resulting in 260 trials total. This experiment took roughly 43 minutes. Each video was trimmed to be 3.1 seconds in length. And the onset of prosody, or when the actor actually began talking, was at 1.1 seconds into each video. All of the videos were luminance controlled to ensure the same amount of light was hitting the participant's eye for each video at every moment of each video throughout the experiment. So hopefully these videos will play well. So this is an example of our neutral stimuli for one actor.
Kids are talking by the door.
Now I will show you a low intensity angry video.
Kids are talking by the door.
And finally, a high intensity video.
Kids are talking by the door!
As I previously mentioned, there is controversy regarding emotion processing in ASD, with some studies finding no difference at all in pupillometry responses. It is possible that these discrepancies are due to the use of stimuli that are so extreme that we're running into ceiling effects. For instance, in the high intensity video I just played for you, most people would be able to tell that person was angry, regardless of whether they have autism or not. We selected these stimuli for our study in part because they offered both a low and a high intensity version for each emotion. We predicted that differences would be most pronounced for the low intensity conditions. Each trial had this structure, began with a blank screen, and then a fixation cross that was gaze contingent, meaning that the participant had to actually be looking at that cross for a full 400 milliseconds before the trial would continue. Then the emotion movie played, and following, participants were asked which emotion did they see, and then they were asked to subjectively rate on a scale of 1 to 9 how intense they believe that emotion to be. For the analysis, of the eye tracking data, we started with standard pre-processing steps. Feel free to ask me if you want details on what those look like, or you can ask Dr. Mclean Sagers, as my code was adapted from what she did from an earlier study. All the pupil diameter readings were averaged into 100 millisecond time bins. And the average diameter for the neutral condition was subtracted from each emotion condition. That way we could ensure that any pupillary responses we saw were due to the emotion itself and not just because there was somebody on the screen talking to them. We began our analysis at 2100 milliseconds into the video. And that is because the person didn't start talking until 1100 milliseconds into the video. And as Bergman et al. Found in 2003, it takes approximately 1 second for the pupillary reflex to peak. We did remove one participant as an outlier. His readings were more than 3 standard deviations away from the mean. And for our second part of our analysis with regards to the questionnaires, we calculated a composite score for ASD traits where we combined the autism spectrum quotient, the broad autism phenotype questionnaire, the repetitive behaviors questionnaire, and the social responsiveness scale for an overall reading or an overall score of autism traits. We also calculated Pearson's product moment correlations for our a priori subscales of interest to determine whether mean pupillary responses were related to the subscale score. This was followed up with an exploratory analysis to look for unexpected relationships between subscales and changes in pupil diameter. So these are the results of just the average pupil diameter by emotion for low and high intensity. And as you can see, we found significant differences between anger, between the low and the high intensity conditions for anger, fear, and surprise. And we had a trend in the difference between high intensity and low intensity happy expressions. Okay, I'm going to walk you through this slide, and then I will show you all the other emotions as well. But just to start, on the x-axis, we have time in milliseconds. Once again, those were 100 millisecond time bins. And then on the y-axis, we have average pupil dilation in millimeters. The dark solid line represents the high intensity condition for anger, and the dotted line represents the low intensity. The gray around each line, it represents standard error. The single arrowhead at 1100 milliseconds is when the person began speaking or the onset of prosody. And the double-headed arrow at 2100 milliseconds is when our analysis began. Once again, because it takes approximately 1 second for pupil diameter to peak. If there's a significant difference between the two conditions, as there is for anger, that is represented with the line with the asterisks above. Okay, so you just saw the anger one in the top left, and there were significant differences for that. There were also significant differences for fear, happy, and surprise for at least some time points within that last second of video presentation. There were no differences or significant differences between the high and the low intensity conditions for sad or disgust. And as such, we decided to collapse those two conditions together for the rest of our analysis. As I mentioned, we created a composite score for autism traits. And in this graph, autism symptom severity is on the x-axis, and the further to the right you go, the more severe the autism traits. And then again, average pupil diameter on the y-axis. For this study, we found that the more severe autism traits a person has, the more likely they are to have reduced pupil diameter compared to individuals with lower ASD traits. Now we'll move into our a priori subscales of interest. As I show you these, again, on the y-axis, that is percent or pupil diameter changes. And then on the x-axis, we have the different emotions: anger, fear, happy, surprise, disgust, and sad. As a reminder, this is after we had subtracted neutral from all of the conditions. And if something crosses the dotted line, that means it is a significant finding. So for instance, fear in the low intensity condition on the AQ social skills did reach a significant difference. As with the composite scores, increased autism traits for these subscales are negatively associated with pupil diameter. Oh, sorry. And we found this for autism, the autism quotient and social skills, and the communication subscales. For the broad autism phenotype questionnaire, we predicted that the aloof personality subscale would be related, and indeed we do see that is the case. And again, I would like to point out the negative pattern of association, even if they did not reach significance. For the multidimensional social competency scale, we predicted that social motivation and social inferencing would be related, and we do see some significant results for certain emotions in those two subscales. We also predicted that there would be a significant relationship for the demonstrating empathic concern subscale and the social knowledge subscale of the MSCS, but we did not reach significance for any condition with either of those two subscales. And finally, the social responsiveness scale, we had predicted ahead of time that social motivation would be related, and indeed it is. We also predicted that social awareness and social communication would show significant results, but those two subscales did not reach significance. Finally, we did an exploratory analysis for all the other subscales just to see if any were related. And we do see that for the repetitive behavior questionnaire in the rigidity and the preoccupation subscales, we do find significant relationships. However, I should note that these did not survive multiple comparisons. But the fact that almost all emotions showed some relationship with the rigidity and the preoccupation subscales indicate that this association should be explored in further studies. So in summary, larger pupil diameter changes were found for high intensity anger, fear, happy, and surprise conditions. Higher autism composite scores were associated with less pupil dilation changes across all emotions. Subscales relating to social skills, communication, motivation, and aloof personality were all associated with reduced pupil responses to some low-level emotions. And these results suggest that individuals with higher rates of autism traits are less able to pick up on subtle displays of emotion, especially for fear and anger. So now moving into objective 3, I will describe the results of an in-progress study. We were hoping to be much further along, but multiple testing days that we had set up had to be canceled due to COVID-19. So I'm showing you the data that we were able to collect before everything was canceled. So we have collected data from 32 participants. Their mean age is 19.3, but their age range is between 8 and 32. I forgot to include that, sorry. And then 36 typically developing participants, roughly within the same age range. We used the same setup as experiment 1, the Tobii eye tracker, the videos. We did not ask participants to use a chin rest, as I'm sure you can imagine, not many children are willing to do that. But luckily, the Tobii eye tracker is able to accommodate those sorts of changes and let us know when a person is moving forward or backwards too much. We decided to shorten the experiment, and we used 10 actors. 5 male and 5 female. And we tested only 4 conditions for this experiment: neutral, and then angry, fear, and happy, both in the low intensity and the high intensity conditions. There were 10 trials for each condition for a total of 70 total trials. And this experiment took roughly 10 minutes to complete. The actors we selected were based on the accuracy scores from the top 10 actors in the previous study. Okay, so as I mentioned, this is an in-progress study. I'm showing you the results from the autism participants right now. And the dark solid line represents the high intensity anger. And again, this is after we've subtracted the neutral condition. And the dotted line represents the low intensity anger. And once again, the x-axis, or I'm sorry, the y-axis represents the mean pupil diameter. And over the course of the experiment, you can see that the results are much closer to each other. At 2100 milliseconds, when we will begin our analysis, there does not seem to be as much of a difference as there was for the previously described experiment. Now moving on into the fear condition, we do see more of a change in this condition, but we will have to compare that to the typically developing participants to know how significant that change is. As I mentioned, the study is in progress. And then finally, for the happy condition, we see almost no change regardless of the condition. And this very much supports the findings of Cepeta et al., where I described the lack of a social reward that they reported back in 2012. We are seeing that there is not much pupillary change regardless of whether it's low intensity or high intensity for individuals on the spectrum. If we compare these results to, for each emotion, collapsed by emotion, compared to the neurotypical participants, in the dark gray is the autism group and the light gray is the neurotypical group, we do see a significant difference in both the fear and the happy conditions. So their pupils are responding differently than their neurotypical peers. And in the, if we just look at it by intensity, so whether it's high intensity conditions, regardless of which emotion it is, or low intensity conditions, we see that there is a substantial difference in the low intensity condition. So this means that individuals on the spectrum are not responding to low intensity emotions, regardless of what emotion it is. Their pupils are not responding as much. So these results suggest that individuals with higher rates of autism traits are less able to pick up on subtle displays of emotion, especially for fear and anger. Autistic individuals are less able to pick up on more subtle emotions and have significantly less autonomic responses to low-level fear and happy expressions. From a clinical standpoint, these results are relevant because if we can work on improving emotion recognition skills in our patients, whether that is by trying some forms of intervention, teaching them subtle ways to pick up on those cues, or saying, okay, if they're struggling with these face expression analysis, perhaps we should teach them other things to look at for, like body language, which has been shown to be a little bit more intact for some people on the spectrum. So if they're struggling with those social interactions and knowing whether somebody's happy or upset with them, we can try and teach them some other ways to figure it out if they're struggling with picking up on the subtle facial cues. And also importantly, for those of us that work with families, we can inform the families that this is an issue. This is something that many people on the spectrum struggle with. And by providing families with that insight, we can help to encourage a more holistic look at this, more compassion, more patience, so that families can better understand why their child is struggling with something and hopefully work out other ways to approach the issue, so that instead of saying, why don't you know when I'm mad at you, saying something like, I know that you struggle to know when somebody's upset. Why don't we try and approach it this way or that way? I would like to acknowledge Dr. Ryan Stevenson, my supervisor, the members of the lab that directly contributed to this project, and our various sources of funding.
Thank you, Fakhri. That was fantastic and a really nice overview. And what's great is I think one of the rules of theater is to leave them wanting more. So we've got lots and lots of time for questions. So I think what we've done in the past, or we did last time, was people can raise their hands, I think, or actually, yeah, I forget how to do that, to be honest with you. So if people have questions, if they want to ask them in the chat, then we can ask them out loud. So Fakhri, why don't I start while we wait? What you've done, it mostly is take people, university students, who we don't know for sure if they have a diagnosis or not, correct?
Correct.
So, and although we talk about a spectrum and a continuum, I think medicine, unfortunately, is based on you either have something or you don't, which may or may not be correct. So, I mean, do you think that we can take the results that you have and extrapolate them to people who have the full syndrome, or who've been diagnosed with autism? And I guess because they haven't been diagnosed doesn't mean they don't have the full syndrome, but I guess that's an open question.
It is an open question, and it's one that is definitely argued within the literature. Can we really say that somebody who doesn't have the spectrum, or who doesn't have a diagnosis, is somewhere on the spectrum, while others, especially from an RDoC approach, would say, well, everybody's somewhere on the spectrum, so we are able to look at the total number of traits. I would say that by looking at all the different questionnaires and dividing it based off of or looking at their answers to this, if anybody has a lot of sorry, I'm seeing the pop-outs of the chat. I would say that it is something that is a bit difficult to be able to parse out whether we can really extrapolate this to the general population, or to the autistic population, but it's a place to start. And then we follow up with studies like my second study, where we say, okay, does this still hold true for individuals with a confirmed diagnosis?
So one question, actually several questions that sort of followed up on that. So one of them from Afia, I think is how it's pronounced. I'm not sure. I apologize if I've butchered it. Would be around. Question was about more for people with verbal abilities and without, but I guess we extended people with different cognitive abilities, so that any test like this unfortunately requires people to be able to participate. And I guess it's hard to comment about how people who can't participate would do. But if we were asking you to speculate, what would you say?
I would say one of the benefits of this study is that we can just look at their pupillary responses. We don't have to look at, ask them to respond, which emotion did you see? And I did forget to mention that we took away the second question about intensity ratings for our participants in the autism study. We wanted to make it a little bit easier and not ask them a subjective question like that. So one of the benefits of this study is that as long as somebody is looking at the screen, which because of the gaze contingent trial control, if they're not looking, the experiment pauses. We can do something like this with infants. We can do something like this with people who are completely nonverbal, and the experiment will pause until they're looking at the screen again. And since these videos are just 3 seconds, as long as they can keep their attention for 3 seconds at a time, we can make inferences regardless of their verbal ability or their cognitive ability.
And that's the great thing about the technology, I think, that you've got, that you can do that even for short little snippets, which is fantastic. Right. So a question from Diane Rogers about how, and she apologized for perhaps missing it, how you separate out people with autism from without. What cutoff did you use? And I can't recall.
Within the first study, we did not set a cutoff amount. We did pay attention to see if anybody was above a certain score on the AQ, but all of these are just screening measures. We can't run an autism or an ADOS or an ADRI, or we can't run any of those diagnostic tests in the lab for our undergrad studies, but within our autism study, we did confirm diagnosis using the ADOS.
So another question that came from someone is, how would you, if people are resistant to doing social skill stuff, when you talk about training, which is a really neat idea, but how well, I don't, how can you can lead a horse to water kind of thing, but any suggestions about that?
I know that there are some groups that are working on basically kind of video games that will help teach face emotion recognition skills. Jim Tanaka out of University of Victoria has something called the Let's Face It program, where they're trying to teach emotion recognition skills. There are a number of groups that are also working in the virtual reality, where autistic individuals can have an avatar and they're in a separate little world, and they have these social interactions, and they're able to practice and learn, oh, this avatar's expression means they are feeling this way or that way. So I think there's a lot of promise in those areas, but thus far, to the best of my knowledge, these training paradigms have not yet resulted in real life or in skill gains in real life, meaning that people get better at the video game, but that isn't necessarily transferring to their social interactions in the real world. So I think it's an area that is constantly being explored, and I believe we will see some interesting things in the next 5 or so years as people embrace more of this technology and as it becomes more affordable.
So Hale, Mclean had a question again about sort of, if we think about the wide range of people with autism and people with intellectual disabilities, and his question was, do we know anything about the response to people with autism who do or do not have intellectual disabilities? And I guess the flip side of that coin or something has to be, what do we know about people with intellectual disabilities who don't have autism, if we were going to compare those two groups?
That is something that, unfortunately, if you look at the literature, a number of studies will say we did not include individuals with intellectual disabilities, because it becomes difficult to separate, are the results we're seeing the result of intellectual disabilities, or are they related to autism itself? So unfortunately, there's very few studies that actually include people with an IQ below 75 or 70, depending on which study you're looking at. So to the best of my knowledge, the few studies that do include it are finding that there are some similar difficulties, but we don't have many studies that have looked at that, unfortunately.
Yeah, you'd almost have to have 4 sort of groups, and you'd have to have sort of people with IQs above 70 with and without autism, and then people below 70 or 70 and below with and without autism. But I think it's a substantial subgroup of people with autism, and something needs to be considered, but perhaps methodologically might be much more difficult. So Professor Dr. Julio Martinez had a couple of questions. So first of all, how do you know that individuals with autism are paying attention to the subject? Don't you need gaze data in order to make sure that subjects are actually attending or engaged with the subject?
Yes, and we do have that gaze contingent trial control at the beginning. Unfortunately, the way the software works, we are not able to pause the experiment in the middle of the video if they look away. But what I did do is create areas of interest. I didn't get into this data because this talk was going to be really long if I talked about everything that I collected with it, but I created areas of interest for the video. So eyes, mouth, and then I also created one for the face itself and the entire screen. So any trials where participants were looking away from the video or from the face itself, we are flagged so that I can remove them. And if enough of them are removed, then that participant, we're not able to say we have enough data for that participant.
How much do those devices cost?
I believe it was 33,000, but you would have to ask Ryan about that. He's the one who purchased it with our various funding sources, but I want to say it was in the $30,000 range.
Yeah, I have a patient with Rett who used one. I think her mom said it was about $25,000-$30,000. So yeah, extraordinarily expensive. The second question, then Tim will come to you afterwards, is so if this is potentially related to autonomic reactivity, have you, I guess Julio's question was why not use heart rate or skin conductance, but I guess the other part of that would be, have you looked at that in addition to pupil dilation?
That is something that I would like to add to our studies. In general, attaching something to children on the spectrum makes for non-compliance issues, is the best way to say it. So while I do believe it would be beneficial to include heart rate and skin conductance, it is not something that I've done thus far. I am very interested in it, and I do agree that including that information can give us a better picture of whether the responses we're seeing are systemic or is it really just based off of what's happening in the emotion processing realm.
So Jennifer Mclean, a pediatrician, developmental pediatrician here at CPRI, mostly had kudos. So very interesting, and it really moves forward the eye tracking studies of differences and in facial recognition, identification, and understanding that, and training. And apparently, since everything gets cheaper with time with technology, apparently it's only $15,000 now, according to Dr. Seegers, who may know Dr. Stevenson reasonably well, and be able to ask him directly that question. Dr. Goldberg, I will press the allow to talk button, and you, Ben, if you can unmute yourself.
Okay, can you hear me okay?
Yep.
Okay, the question I asked, is there a difference in the recognition of other emotions, that's empathy, versus recognition of personal emotions? Did that come into your research at all? Identify others' emotions versus personal emotions.
For the first study, sorry, let me back up for a moment. With regards to identifying other people's emotions, that is what I was most focused on in these studies. But it is important to note that a number of individuals on the spectrum have something called alexithymia, or also meet criteria for alexithymia. And alexithymia is an inability to recognize emotional state in oneself. Sensory perception research has also suggested that individuals on the spectrum struggle with interoception, so recognizing internal body states. So while I did not assess that in the first study, we did include a questionnaire for alexithymia in the study of children and adults on the spectrum in my second study, and I will be looking directly at that to see, is there a relationship that we can find.
Fine, thank you.
It sounds, Fakhri, so you guys have a mountain of data and almost sort of too many papers waiting to be published or written up. Julio, you had another question, I believe.
All right, I would like to first thank Dr. Goldberg. Apparently he gave us $3,000 to purchase towards the purchase of the eye tracker. So thank you very much, Dr. Goldberg. I really appreciate it.
Yeah, Rob was the one that made the decision.
I did? Oh, well, good for me. Apparently it was well used.
Thank you to both of you then.
It's Dr. Goldberg entirely. I will take none of the credit for it, although I'd like to. Julio, you had another question for Fakhri. You just have to unmute yourself.
Sure. No, I'm thinking that it was mostly a comment that the Toronto group at some point had an app in which they were actually tracking skin conductance and heart rate. I don't know if you remember that, Rob, with the PONT, that was part of the PONT group.
Sorry, somebody had just texted me something about something. I missed that, Julio.
That the Toronto group has an app that was looking at the skin conductance and was looking at the heart rate in individuals. And one of the problems that they had, that they couldn't distinguish happy from afraid. So basically, because the way the autonomic system actually works is that those emotions would produce increase or decrease in autonomic responses depending sympathetic or parasympathetic. So I just wanted to say that would be really interesting to see if the pupillometry can tell us something more than what these measurements tell us.
Very interesting, thank you. And you said that was through PONT?
I believe there was an engineer through PONT, and it was working with the group at Sick Kids.
At Sick Kids, great. I will definitely check into that. Yes, I appreciate that information, thank you.
The other person who might be of interest, Fakhri, is Pancho Barrera, who's a behavioral psychologist who's worked in this field for a long time and has done a lot of stuff, I think, around heart rate and I don't know about skin conductance, but certainly heart rate and autonomic reactivity. A lot of it in relation to self-injurious behavior, but I think has a fair amount of experience with that kind of equipment, including I think he had a vest that people could wear or something like that at one point in time.
Wonderful, thank you very much.
Other questions or comments for Dr. Shafai? We have 8 minutes, so we can just sit here and look at each other. So Fakhri, where to from here? What are your sort of future plans?
Well, I'm not sure if I can say I've officially, or I know I haven't officially gotten it, but unofficially I have a MyTax internship coming up with CASDA, the Canadian Autism Spectrum Disorder Alliance, and I will hopefully, fingers crossed, be working on their COVID-19 rapid response project. So part of that effort will be to compile resources from across Canada for families so they can go to one place to find information on ways to approach COVID-19 and how to best support their children. But also for researchers, anybody who's looking at it can send their research, their resources, if they have surveys that want to come out. All of that can be found in one place. And then the part I'm the most excited about is we'll be doing weekly meetings with both researcher groups and leaders from across the community disability groups from across Canada. And we will be creating recommendations to the federal government to be presented in October. So ways in which individuals on the spectrum and their families have been impacted by COVID-19 and creating concrete recommendations for changes in government policy so that we can both help them now and prevent these pitfalls in the future, regardless of whether it's a pandemic, natural disaster, or whatever. How do we bridge these gaps now?
So I should have said earlier, and I apologize, Fakhri, but Fakhri also has done a lot of work with Autism Ontario and has organized a series of talks repeatedly for Autism Ontario. So it's done a lot of outreach work with the community as well. So another question that came up is, do you from your knowledge, think alexithymia is part of autism or separate from it?
That's a great question, and it's one that I think a lot of us are looking at. From the research that I found, at least 40% of people on the spectrum also meet criteria for alexithymia. I think one of the issues that we run into is because autism spectrum disorder is so heterogeneous, we can't say that it applies to everyone because everybody's an individual, everybody's unique, but there is certainly a large amount of overlap. And the question becomes, well, if we can train people to better recognize emotions in themselves, can that eventually cause them to be better able to recognize emotions in others or vice versa? And I think that's an area that's ripe for research, but I'm not aware of any groups that have found anything beyond an association at this point.
And again, I think that people with what Kenner would have called autism, I think that's a really difficult question to answer because those people with sort of more classic autism, I suppose, are not going to be able to provide us with verbal answers to those kind of questions. And so it remains an unanswerable question. So I should say here also that if anybody hopes to get credit through a professional organization for this talk, people need to have made sure they've checked in using their name. Somebody is registered as reception, which I suppose could be their first name. But if people want credit, we need a name just so we know who to send the certificates to. And Diane Rogers had a comment again about this was a wonderful talk, which I think echoes what all of us have to say, Fakhri. So if there aren't any other comments, I think this was a great way. Yes.
Can I say one more thing? Just a little plug. I was recently hired as a consultant for a project with AID, or the Autism and Intellectual Disability Developmental Disabilities Knowledge Exchange Network, and we created some toolkits on the AID website. You can go to aidcanada.ca. And
AIDD though?
AIDE, yes. AIDEcanada.ca. And it's a wonderful project where we will be creating numerous toolkits for families to be able to access. One of the toolkits I created was on sensory processing differences, and I do provide information on how to teach those introspection skills to your child if they are struggling with understanding what's happening in their body. So I would highly suggest people check that out if they can.
That sounds really valuable, actually, and very clinically relevant as well. So I think this was a wonderful way to finish up the academic year, Fakhri. This was a fantastic talk and a really nice summary. And so we can't thank you enough, but this was wonderful. Thank you everybody for attending. And again, we will try and get certificates out to people who want them. Take care, stay safe.
Congratulations, Rob.
Yep, thanks, Ben. Take care, everybody.
I know. Making it through the pandemic year.